For a known amount of current flowing into the formation, the measured potential between the M electrodes and an electrode considered to be at a zero voltage or zero potential reflects formation resistivity. These zero potential electrodes may be on the surface or downhole, but generally are suitably distant from the other electrodes. If we were to place a second set of guard electrodes closer to the source, then the depth of investigation would be shorter for this new array.
In turn, this dual depth of investigation logging with further signal processing can give us a plot of undisturbed formation resistivity and flushed and/or transition zone resistivity from a single logging pass. Let's look at typical resistivity curves measured by a dual system such as this.
Typically, we can obtain a curve measuring deep resistivity, a curve measuring shallow resistivity, and a curve measuring very shallow resistivities in the flushed zone just behind the mud cake. To determine resistivities and invasion diameter, we start with the example we saw earlier. The voltage drop measured by a deep resistivity tool measures the voltage drop caused by mud resistivity plus invaded zone resistivity plus undisturbed zone resistivity. Now, if we remember that voltage is equal to current times resistivity times a tool constant geometry, or V equals I times R times K, then we can state that the voltage measured by a focused deep reading device is equal to the current, I, times the resistivity of the mud, R sub M, adjusted for the whole diameter, plus the resistivity of the invaded zone, R sub XO, adjusted for the invasion diameter, D sub I, plus the formation resistivity, R sub T, times the contrast between the formation and the invasion zone resistivity, all times the tool constant.
In this situation, there are three unknowns: the resistivity of the undisturbed formation, the resistivity of the invaded zone, and the diameter of the invaded zone. These three unknowns can be determined by using three equations implementing three resistivity measurements.
The mathematics involved in making final determination of resistivity are complex and include the use of a pseudo-geometrical factor, J.